In this video, I will be talking about the huge effect that polymers have had on sport. A polymer is a very high molecular weight compound made up of a large number of simpler molecules of the same kind. Most plastics are man-made polymers, while proteins are natural polymers made up of amino acids. Here is a list of sports equipment containing polymers. To explain the importance of polymers in sports, and specifically in cricket, I'm going to use my own equipment as examples. My first example is this helmet. It's got a polypropylene shell and contains acrylonitrile butadiene styrene, which is commonly shortened to ABS. This is a thermoplastic. ABS is made of these compounds. Thermoplastic is a synthetic plastic or resin which becomes soft when heated and rehardens when cooled without appreciable change in properties. This is the structural formula of polypropylene. Carbon fibre is used as this is more protective and lighter. My next example is my batting pads. This particular pad has a covering made of polyvinyl chloride, which is commonly shortened to PVC. PVC is made by a free radical chain growth mechanism. Initiation is the first step of a free radical mechanism. This involves an initiator. In my example, I'm going to use a general peroxide. The oxygen-oxygen bond in this case breaks, causing an electron to be donated to each side of the bond, forming two radicals. One of these radicals reacts with your chosen monomer, and this forms a radical containing your chosen monomer. Propagation. The second step in a free radical mechanism is the propagation step. This involves the radical that you created, including your monomer, from the initiation step. The radical electron and an electron from the carbon-carbon double bond in the monomer form a bond, and another electron from the carbon-carbon double bond forms a radical on the adjacent carbon. This can be repeated as many times as you have monomers, as it's only limited by the amount of monomer. Termination. The final step of a free radical mechanism is termination. There are two ways to terminate this mechanism. The first and more favourable is chain combination. This involves two chains, and these both contain a radical. The two radical electrons are donated towards forming a bond between these two chains. This creates a much larger chain. The other less favourable termination step is disproportionation. This also involves two radical chains. However, in this, the radical electron from one chain and an electron from the carbon-hydrogen bond in the other chain form a bond between this carbon and the hydrogen. The other electron from this carbon-hydrogen bond is donated to this carbon-carbon bond, and so is the radical electron in this chain. This forms a double bond, creating two chains. Another polymer used as a covering is polyurethane. These are both good to use as coverings as they are cheap, durable and easy to clean. However, polyurethane is more readily recyclable. This is the structural formula of polyurethane. We also have a PVC covering. My next example is my thigh pad. This contains a mixture of polyesters. These allow increased protection and make it light. My next example is my cricket spikes. These particular spikes have a nylon meshing. This allows it to be lighter, more protective, and has added comfort and ventilation. These are the structural formulae of two types of nylon. Cricket spikes contain Vectran, which is an aromatic polyester. This allows the spike to be light and have increased strength and support. This is the structural formula of Vectran. Some cricket spikes contain PBAX. This stands for polyether blockamide. This is a thermoplastic and allows the spike to have lower density, has good damping properties and energy return, and allows the shoe to be more flexible. This is also an elastomer. An elastomer is any rubbery material composed of long chain-like molecules or polymers that are capable of recovering their original shape after being stretched to great extents. Under normal conditions, the long molecules making up an elastomeric material are irregularly coiled. With the application of force, however, the molecules straighten out in the direction in which they are being pulled. Upon release, the molecules spontaneously return to their normal, compact, random arrangement.